Hello, viewers. Welcome to another episode of Amazing Maths Problem. So today we'll be looking at concentric circular bent root tangent problem. So here goes the problem. I believe you can see clearly on the screen. So the question said a bend in a road is formed from two concentric arc with inside radius r and outside radius r, each of a third of a circle with the same center. You can see it clearly in the diagram. So let's try and do just a brief sketch of what we are talking about. So these two circles have the same center. So let's call this to be their center. So the first circle is the smaller circle. So let's indicate it by this circle. And the other circle is the bigger circle, which is this circle here, right? Now, these two circles are a third of a circle with the same center. When a circle is a third of a circle with the same center, it means that the ratio of the length of the arc of the circle and the circumference of the circle is 1/3. And that can only be possible when the angle subtended by the circle is 120 degrees. So it means that the smaller arc and the bigger arc subtends an angle of 120 degrees. Okay, so now let's illustrate that. So it means, as you can see in this diagram now, so the hidden line you see here, so this hidden line, so this is actually what 120. So this angle here is 120. So now the road is then formed of tangents to the arc. So let's draw the tangent. The tangent is just a straight line. So there's a straight line that goes like this, tangent to the first circle. There's another straight line that goes like this. So since they are concentric, these two lines has to be parallel. Similarly, we have another straight line that goes this way and that goes this way. So this is how the road looks like. So this is where the tangents, the cyclists can go through. But they said the cyclists cut the corners by following an arc of radius x, so which is tangent to the outside of the road. So let's draw the circle they are talking about. So now the circle is actually tangent to the outside of the road, which means the straight line here. So this is what they're actually saying. So it comes like something like this. Then it's now tangent, is tangent to the inside, is tangent to the outside of the road and at its end, and tangent to the inside of the road. The inside of the road is this part, right? Which means the circle goes like this, as you can see the way they draw it in the figure. So it goes somehow like this. So this circle will also have its own center. So let's say the center of that circle is, let's call it somewhere here. So now they said we should prove that r plus x, remember r is the radius of the small circle, plus x is the radius of the big circle, is equals to k times big radius, the radius of the big circle, for some number k. So let's try to finish up this problem. So first thing we need to do is that we need to try to get all the dimensions. So again, another thing I would like to do is to draw a straight line from this place to this end, this place. So let's call the center of this concentric circle O1, and let's call the center of this concentric circle here O2. Now, so we can make this diagram to be more geometric. So what I mean that make it more geometric is that we know that if we draw, if we extend this line, so let's extend this line, it's going to meet somewhere, right? So let's say it meets somewhere here. Okay, good. So let's call that point where it meets A. If we also extend this line, this tangent, let's call it B. Now it is easy for we to see that B, if we join the line A, B, O and O1 and O2, is going to be a straight line because this whole thing is symmetric, right? So that's the first thing. Also, so we have to do some labeling. So I'm going to draw this line, complete it. So I'm going to draw, okay? So that's first thing I want to get. So let's call this, okay, so let's do some angle chasing. So this angle here is going to be 90 degree because the straight line and a tangent meet at. Now this O1 and O2, they are going to be parallel to each other because they are two perpendicular lines. Just imagine you have two lines that are straight and then you have two perpendicular lines. Then those two lines has to be perpendicular, right? This is also 90 degree. Good. All right. So now we call this to be B. Let's label this point to be, let's call it, so let's just label some points here. So we've called this B. So let's call this to be, let me say, let's call this to be C. Let's call this to be D. So let's call this to be E. Let's call this to be F. Okay. Let's draw another line that is parallel to these two lines, but at 90 degree to EF. Such that this line here is this angle here is 90 degree. So let's call this point M. Okay. So now because this angle here, this angle, the angle sustained by the two arc is 120 degree because they are each of them are a third of a circle with the same center. So this and this line AO1 O2 is a angle bisector. That means that angle has to be what? Has to be 60 degrees. So let's call it yellow angle. So this yellow angle here is 60 degree. So this one too is also 60. Okay. So let's do some other angle chasing. So yellow angle is 60 degree. Okay. Now let's do some other angle chasing. So um line CO1 and EO2 are parallel to each other. So this is also 90 degree because this is 90 degree. Okay. So now we have one more angle that we need to chase, which is this red angle here. So let's call this a red angle. So the red angle has to be 30 degree since sum of yellow plus red has to be 90. Okay, so now looking at this angle here is also going to be red because of that will be these two angles are they are corresponding angles, as you can see the two angles. Or if we, if it's not corresponding, you can actually get it from the fact that this angle here is going to be yellow. So it's this angle that is corresponding, right? Forming something like an F. So let me show you guys. So the angle goes like this. I hope you see it. So if this is yellow here, this is also going to be what? Yellow. So that's like an F angle. So even though we cannot say this angle, these two red angles are corresponding, we know that using the fact that yellow plus red has to be what they call it 90. So this has to be red. All right. So now let's try and do some kind of calculations of the size we have. So first, what is DO1? DO1 is the radius of, you can see the arc of that circle. So that means DO1 has to have a radius of R. Okay. So first, what else again? So we want to look at there are a lot of triangles that are similar, but we just want to pick the ones that is sufficient for this problem. So consider triangle BDO1 is actually similar to triangle opposite sides of a rectangle. So it means that MO2 now be what? EO2 minus what? EM, which is going to be what? That will be X minus big R. Now let's find what O1, O2 is. Now O1, O2 is going to be, let's even call these points. We didn't give it a point, so let's call this let me just call it G. Now, from G is on the red to O2 is X. That's the radius of the red circle. So this is the same as GO2, right? Both of them is X. Now O1, O2 is actually X minus GO1, and GO1 is the same as DO1 because those are common radii of the smaller circle. So it means that O1, O2 is going to be what? X minus R. So let's find what some other side is going to be. So using the ratio of similarity, so let's start the green angle. Let's start with triangle BDO1. The green angle here is facing BO1. So BO1 over, so the green angle in the other triangle O1 MO1 is facing O1 O2. So B is equals to, so we just pick another side. So the red angle is facing DO1. So DO1 over the red angle there is facing M2X minus X plus R is equals to 2 big R. So 2x minus x is x. X plus r is x plus r or r plus x. So r plus x is equals to 2r. So which is the same as what they asked us to prove. So what they asked us to prove is r plus x is equals to kr. So when you compare the two equations, k has to be 2. So, uh, so that